Hello dear students, today we'll talk about valency factor or the N factor and calculations involving equivalent masses. Valency factor is also called as an equivalent factor, and this factor carries significance in calculating equivalent mass of substances. That is, equivalent mass is equal to molecular or atomic mass divided by N factor. So, for the calculation of equivalent mass, you must know the value of N factor. Now, substances under different conditions possess different N factor values. Whether the substance is a metalline, elements, acids or bases, reducing or oxidizing agents, etc. Now, how can you find N factor values in each of these substances? Let's have a look. For metals and elements, N factor is given by N factor is equal to the maximum charge. For example, for calcium, as we know, the maximum charge is 2 because it belongs to alkaline earth family. So therefore N factor is equal to 2. Similarly, for oxygen, the maximum charge is equal to 2 as oxide. Therefore N factor is equal to 4. In the same way, for nitrogen gas, maximum charge is equal to 3 as in nitride. Therefore N factor is equal to 6. In each of these examples, you are asked to find the equivalent masses. So next, talking about the salts, N factor is equal to charge on cation multiplied by the number of cations. For example, for NaCl crystal, as sodium ion is the cation having a charge of +1 and the number of sodium ions is equal to 1, therefore total charge on cation will be equal to 1 into 1, that's equal to 1. So N factor is equal to 1. For magnesium chloride, magnesium is having a charge of +2 and there's only one magnesium ion in it, so total charge on cation will be equal to 2 into 1, that's equal to 2. So N factor is equal to 2. Similarly, for aluminum sulfate, total charge on cation will be equal to 3 into 2, that's equal to 6, because aluminum is having a charge of +3 and there are 2 aluminum ions in it. So N factor will be equal to 6. In these cases also, you are asked to find the equivalent masses. Now, for acids and bases, N factor is equal to the number of H plus or OH minus replaced from acid or base respectively. For example, for HCl, N factor is equal to 1 since there is only one hydrogen to be replaced. Similarly, for sodium hydroxide, NaOH, as there is only one hydroxide ion that can be replaced, so N factor is equal to 1. In the same way, for sulfuric acid, H2SO4, since there are 2 hydrogen ions that can be replaced, so N factor is equal to 2. Similarly, for magnesium hydroxide base, as there are 2 hydroxides that may be replaced, so N factor is equal to 2. But there is an important point to make is, if in a reaction only one H plus or OH minus is replaced, then N factor is equal to 1. For example, upon reacting sulfuric acid with sodium hydroxide, we are getting sodium bisulfate and water. Now in this case, sulfuric acid is giving only one H plus ion, so N factor will be equal to 1. In the case of oxidizing and reducing agents, or we can say redox reactions, N factor will be equal to the change in oxidation number multiplied by the number of atoms. For example, in the conversion of permanganate to Mn2+, the oxidation number of manganese in permanganate is +5. So there is the change in oxidation state of 3 and there is only one manganese ion present. So N factor is equal to 3 into 1, that's equal to 3. Similarly, for the conversion of iron third to iron second, as the change in oxidation state is 1 and there is only one iron atom, so N factor is equal to 1 into 1, that's equal to 1. During the conversion of dichromatine into chromatine, the oxidation state of chromium in dichromate is +6, and hence the change in oxidation state is 3. As there are 2 chromium ions in dichromate, so the N factor value is equal to 3 into 2, that's 6. Lastly, for oxides, so considering an oxide AXOY, N factor will be equal to 2 into Y by X multiplied by number of atoms of A. For example, in case of sodium oxide, as there are 2 sodium ions and there is 1 oxygen only, so Y will be equal to 1 and X will be equal to 2. Therefore, N factor will be equal to 2 into 1 by 2 multiplied by 2. That's equal to 2 as per the formula. Similarly, for magnesium oxide, N factor is calculated to be 2. In the same way, for aluminum oxide, N factor has been found to be 6. This was all about the calculations of N factor values and their corresponding equivalent weights. Now, I'm asking you to find equivalent mass in each of those cases that we have studied so far.